so just forgive me if I mispronounce something. So the question is, what are we talking about when we talk about a radio-based data network? Well, first of all, your home computer is maybe exchanging information with somebody else's home computer. This is very simplified. You go out through a modem and then it goes out into the cloud, comes back in, and you can do keyboard to keyboard stuff. You can do email back and forth. Anything that you do now with the internet, you can do with a radio-based network by just replacing the modems with radios. And these are 5.9 gigahertz radios that I've got depicted here. So two common designs of the radio-based networks. One is an ad hoc mesh network. Arden has software that does this with, I think, across several different product lines. I think they've got Ubiquity Bullets, and they might be supporting Microtik now. They used to support the Linksys, but Linksys kind of aged out on capabilities. So the advantage of these is that they're really simple to configure. The clients can come and go and the network just reseals itself, but you have a scalability problem. So if you, as the network gets bigger and bigger, there's a lot of overhead for the networking protocol, which takes away from the data that you can transmit back and forth. The other alternative is, there's the other common alternative, let's put it that way, is an IP-based network that's a routed network, like anything that an ISP would use well-established protocols. It's a bit of a chore to configure them. They're not quite as easy. And the neat part about it is if you have a routed backbone like this, you can connect small groups of Arden clients on the ends of this, and then they have a backbone transport. I'll get my tongue tied here. So one example of this is the Puget Sound data ring of HamWAN, and you can see a somewhat fairly recent picture of the connectivity that they have. The blue lines are the links between the high-level sites and sometimes the client sites with the small dots. And if you access this live on your on the website, on their HamWAN website, you can actually drill down to see what speeds everything is going. I have a summary of what I picked up today in a couple slides from now. So which is better? Well, I would say neither one of them is better. They actually complement each other. And so HamWAN gives you a very solid data network background, and Arden is easy to deploy with small networks, for small networks. So you can take these out in emergency situations, and you might want to set up a small network at an EOC or out at a shelter or something like that, fire camp, whatever. And if you are within reach of the HamWAN network, you can link back on that, and then you link everybody back to the internet on the other small network. So how fast might you want to go, or could you go? Well, here's a comparison. Are you right now, are you in the slow lane? We've got RMSs at 1200 baud. Some of them are at 9600 baud. You have speed limits for, in part 97.307, there's speed limits all the way up to a V.92 dial-up modem speed. And if you folks remember those are 20, 25 year ago technology. So when you start going a little bit faster, the first one on there is a bonded ISDN channels. That's what they used to use for between courts and such. The attorneys and courts did a lot of video conferencing over that over the years. And then some of the cellular phone technology. My client node is running at 14.4 megabits per second, at least it was just at the start of this talk. And I'm going to a HamWAN node that's 13.4 miles away. The one that we installed at the Washington State Department of Transportation is going about double what I'm getting. I'm not sure why. I've got a tree about 2 blocks away that I partially go through, so that could be part of it. And then you go faster. in different, the Weston building in Seattle that you can see on that first line there, that's where the majority of a lot of the network connectivity takes place in the Seattle area. And then as you go down there's different links to different hilltops from one to the other. And it gets up there pretty good. One of the nodes a few months ago was running at 300 megabits per second. And I haven't seen that speed out of it for a while. I check it every once in a while. So really, what you have to say to yourself now is what they said in the Top Gun movie, what Maverick said to Goose, I feel the need for speed. Is it updating for you, Dan? I'm seeing mine is a little slow.
No, you're doing fine.
Okay, because on my monitor, I'm still like 4 slides behind.
No, we're right with you.
Okay, sounds good. And so, are you entering a golf cart in a NASCAR race? I don't think they're going to compete against each other too well. So why would you build this? Well, you got to think about what you use it for. You know, it complements your voice communications, obviously. You can send images over it, which you can't really do too well over an analog voice radio, although some of the Yaesu technology will let you send pictures, but that's still not very fast. Certainly more accurate. You get fast data transfers, and in an MCOM situation, the record might be subpoenaed in court at some point in time, but you've got a really precise record. So this is an aid to local emergency managers. And then I don't know how many young folks we got on here, but the younger generation really likes the digital stuff. Not so much the talking on the radios. Although the Cowlitz County Net a week and a half ago had I think a 13-year-old net control. So that was actually pretty good and did a really good job. So if you want to link repeaters together, analog or digital, you can backhaul that on this type of a network. Quick email transfers. I participated in the Red Cross, what was it, Thursday drills in January. On the 4th Thursday, I finally checked in, and it just went like gangbusters because I was using this for my WinLink client. And provide live video support for events or parades, marathons, walkathons, you name it. Keyboard to keyboard stuff back and forth with your friends, or transfer files, or you might just want to tinker with the technology. It's kind of fun to tinker with stuff that you haven't tinkered with before. So first off, define your network service area. Who are going to be the users? If you're going to do emergency communications, if that's a priority in your area, which ones are going to be included in this network? And will you connect them with one high-level site or two or more? The Washington State Emergency Management Division has 4 links, and that's the most that I know of. So you have to map this out. You just can't do it in your head. And if we look at some of the reports from like the Cascadia Rising drill in 2016 on the West Coast, that little box there, and it's kind of small, but if you can't read it, it says, existing auxiliary amateur radio processes are slow and not capable of handling the large volumes of traffic expected during an event of this size, mostly due to radio bandwidth issues. So that's what the state of Oregon said in their write-up. And this went out to everybody. But they stated the obvious. We all know this. We are really slow. So we need to be aware of what they think about us. I mean, these guys like us from an amateur radio community perspective, but they know we have limits. Well, do we really have limits, or is it self-imposed because we just haven't adopted the right technology? And so we need to rethink what we have to offer to them and kind of step up and meet those challenges. And this is one way to do it. So let's go finding Hilltop sites. So the tool that I like to use for viewshed analysis is CalTopo, and that URL is on there. So you need to think about what is available from where you want to, where your network's going to be. What sites are available? Are there repeaters up there already? Are some of the sites owned by potential served agencies for emergency communications? It's going to differ by your area. I can't tell you what the answer to that is. But from the easy way to do this is from each user location, go out there with a set of binoculars and just look around for potential sites that you can see. If you can see a tower, well, okay, it's going to work, because the microwave technology is line of sight technology. If you can't see it, it's not going to work. And then write down what you see, and then figure out the latitudes and longitudes of the potential sites. And then again, you might make a list like the one here. This one kind of shows western or southwest Washington and northwest Oregon, and they're talking about building out one of these networks. So, you know, I looked at where all the latitudes and longitudes of all of these repeater sites, their existing repeaters, and this list is far longer than what I could show on the screen here because I've got a lot of stuff. And let's take an example. So I want to set up a HamWANs like a radio network site up in Camas, Washington. So go out to the repeater book. There are 2 repeaters are located on a place called Prune Hill. Well, where's Prune Hill? And have they had too many prunes? I don't know. It's probably what used to be there. So you come up with Cal Topo, and they have, and zoom out a little bit after I went in and selected Camas, Washington, and then I zoomed out a little bit because that brings up the Hilltop names fairly easily. So there's 2 of them that are named Prune. Okay, that's great. So I looked at the south one. Okay, no radio towers there. It's a housing development. Then I looked at the north one. A radio tower, a couple water towers. So then you take another view of it, and here's what what Google shows you for what's there. So I see at least probably 5 or 6 structures there that can hold antennas. There's that tower, regular antenna tower. There's 2 water tanks, each of which have some types of antennas. Some of them are microwave on it. There's an, and I'll have to use the, where's my pointer thingy? Okay, I don't know how to get the pointer up. Anyway, now I've got a dialog box up. It's not helping me.
See your arrow at the top of the screen. It's over the eye in sight.
It's over what? It's over which?
It's over the eye in sight. I see an arrow. Now it's moving over to Hilltop.
Ah. I see an arrow, but that wasn't giving it to me. Oh, well, I'm not going to worry about it. I can just use the cursor. Hopefully you can see the cursor moving around on the screen. So anyway, there's a tower, there's 2 water tanks, there's what looks like a dish up on a pole here. There looks like there's a cellular thing here when you zoom in on it, and there are 4 other poles here, and I'm not sure what those are, but they do look like they have wires on them. So the next thing you can do is go out and use that latitude and longitude that we already looked up and go to the FCC structure, antenna structure database. Lo and behold, that tower that's 57.9 meters tall is owned by Clark County. Oh, that's nice. It's owned by our local county. Maybe we can get an antenna up there because we've got a good working relationship with them. I don't know. They also have a dismantled tower on this list. I've got a few more things on here as well, but this one probably wasn't too big because it was only 12.2 meters, which means it might have been on top of one of those water towers. And to find out who owns the property, well, here's the property highlighted in blue, and that's owned by the city of Camas. Oh, okay, that's good. And just to the east of it along the road, this property is also owned by the city of Camas. And then over here, just to the west, also owned by the city of Camas. And then down here is Columbia Cable of Washington. Those are those 4 other poles that we can see there with wires running in there, and I don't know what they've got up on them. But you can find out if you don't know the repeater owner or don't have a repeater up there, you need to contact somebody. You just have a whole lot of information here about people to contact. So your design, start first about different topologies, and this is going to be theoretical types of topologies. You may or may not do this, but what happens if one of these puppies goes down? Well, your network's split in half, or worse if 2 of them go down, and your network breaks. There's the typical tree structure that's used quite frequently. The network also breaks if one of these key nodes breaks. If that one breaks, or that one breaks, or this one breaks, it goes away, or is divided up. And star topology. Well, if the center of that star goes down, you don't have a network anymore. Ring topology. This is okay. One of these goes down and your traffic can still go the other way around the ring. But if 2 of them break, then you have a little bit more of a problem there. But it will be okay with 1 break or outage. And there's the mesh structures, and this is pretty random. But if something like one of your key nodes breaks, that breaks the network. It doesn't break it completely, but it gets it to the point where one side can't reach the other. So it's semi-fault tolerant. And then there's a full mesh where everything's connected to everything else. But if you look at the number of links involved here and the number of radios, do you really want to be buying 56 radios to do all this? I don't. But it is very fault tolerant. And then if you run it out to 16 nodes, that's 240 radios. And only Dan's the only one I know of that can afford that. There's another option. It's called a hypercube. And this type of arrangement, each one of the nodes on the network has exactly 3 connections. And so any one of them can be taken out and you can still route traffic. So if I take out this one and maybe I take out that one, is it still going to work? Yeah. These 2 folks would be cut off, but the rest of it's still going to work. And you could extend that. You could have like double that and then link them together. Or perhaps a little more simply, you really could get away with only 4 connections between it. So, like I said earlier, your design will probably not be like any of those theoretical models. It's really going to depend on what the terrain, the access, the high-level sites. If you're in a fairly flat land, can you get things up on towers, and can you see those towers? And where are those? Because you're not going to be putting up towers yourself for doing this. You might use some of the hams towers, or you might use a TV station tower or whatever. Those high sites do exist. It's just, can you get access to them? And so your network's not going to be perfectly designed like one of those models there. But you certainly want to be as resilient as you can. So you want to eliminate, first of all, those single points of failure. If one thing goes out, you still want this thing to function. And can you design it so that a couple things would go out and it still works? That's a good challenge. So funding. What's your funding source? Is your ham club rich? Do you have volunteers that are independently wealthy and could just foot the bill, write a check? This is all I need. There are also grant opportunities. FEMA has some. And they come and go from time to time. So there's a bunch of different ones that might be available one time and not another. And that's certainly going to, what funding you have is certainly going to drive your design for your network. So what a typical high-level link site might be is some point-to-point radios that go between other link sites, sector antennas that handle the clients. Some of the ham WAN sites have been deployed with point tilt zoom cameras Neat part about that is back in September, a couple of guys were looking through that and they were able to be the first report of a forest fire. That was kind of neat. And there's a whole bunch of miscellaneous other stuff that you need at the site, down to clamps and U-bolts and all kinds of little things for getting the cable up in the air. So your price depends on how you design it, but that's a pretty good range for what one of the high-level sites would be. A good quality point and tilt zoom camera is about 500, so you could add that on. And if you wanted to do solar power, you add that on it as well. That price does not include that. So from the client side of things, you got small dishes, and these are only a couple feet in diameter. And you have some flat panels. They're not quite as directional, but also put out a pretty decent signal. And I would recommend that everybody that does one of these, they put in a firewall. Now that's a hardware firewall, not a software firewall, because this is a direct internet connection. Client nodes start at $41. That's not too bad. These only go a few miles. You could step up then to a really kind of a small dish. And a little bit nicer dish. Now this happens to be my dish. It's on top of my garage, and that's what I'm talking over right now. And then some of the flat panels that might be really good for taking for a mobile station that you might want to deploy to a shelter or something like that and connect where you can. Somewhat the same price range. And then you can get really kind of fancy and get a fairly nice setup. And this has 30 dBs a gain where most of the others don't. So you can get a little bit more extravagant. But you can start like that earlier one at $41. So services on this network. The things that you might want to have running, some servers running with different applications for the different the users of the network. I'll let you read those. I don't have to go down. And one of the questions you need to ask is, are you going to connect this network to the internet? That adds more complexity, and you could make it run without the internet in place.
Yep.
So you don't have to have it that way. And then if you do connect to the internet, will you have just one connection? Oh gosh, there's a single point of failure again. Or will you use the ham block of IP addresses that start with number 44? Or will you have use like 192.168 or 172.31 or something like that, addresses that don't route out on the internet to keep all the traffic internal. And then on the implementation, well, you need to make yourself a bill of materials, what you're going to need for each site. The Hamman folks have some of those for examples. Those are all different depending on each site, but they all have some really significant commonalities too. And who's going to do the buying for you? Who's going to do the purchasing? Are you going to take it to Dan's garage to store it in? And then where are you going to set it up to configure it? Are you going to try to take it up the hill and configure it? That's not a good idea. Configuring ahead of time would be much easier to troubleshoot. And there are a lot of software parameters that you probably want to find somebody that dabbles in network engineering to help you set up, because these are fairly complex. And then how are you going to test this? And then when you get ready to do the installation, do you have all the tools you need, and do you have enough volunteers? In some places, you need to have certified tower climbers. So that needs to be thought about in advance. And how do you know that it's actually working? Well, you can get a signal out, but is it working the way you thought it was going to work, or is it not? And then you're going to want to monitor this network. And there's probably going to be some routine maintenance. The software is going to have to be upgraded every once in a while. And if something breaks, how are you going to fix it? And for further reading, got a whole bunch of stuff there.
Can you put that in the chat?
I can't right now really easily. The computer that I'm monitoring on actually froze at about 6 minutes after the hour. And I'm going to probably have to reboot it, so I can't do that. But I did send Dan the link to the PDF of this. I don't know if he has a website that he wants.
I have the PDF, and it will go out as they always do right after the presentation.
Oh, okay, good. Yeah, it was a little bit big, so I wanted to let you download it as opposed to trying to send it an email. And so that'll all be there. And two of those links down at the bottom are about the Cascadia Rising exercise, the FEMA report and the Washington report, which also have some very significant comments about amateur radio in there. They're not bad, but they're room for improvement in some places too. And that's it. Got any questions?
Well, let's down your screen, and we'll get some people asking questions. Your desktop.
I hope I didn't go too fast.
No, I think you did just fine.
Nope, you're good. Some questions from chat, if it's okay. Let me know, Dan.
Yeah, go ahead with the chat.
Okay. Someone wants to know, how do you get the signal down to the users who live in a heavily treed area in Puget Sound?
If you've got trees in the way, well, if you got one tree branch, you might be able to get through it, but you have to get around those trees. I could suggest a chainsaw.
Yeah.
Even if it's your neighbors, maybe. No, you have to be line of sight. So yeah, heavily treed. My link, and I probably should have put a picture up of it, actually shoots out between a tree on our property, over top of a tree on our next door neighbor's property, and to the right of a tree that's about 1.5 blocks away. So it's a very, very narrow path. But I was fortunate just to have one.
Okay. So basically, you need more nodes to get around the obstacle.
Yeah, if there were more and I could see them, yes, but I can't see all the hills from where we are because we do have quite a few trees.
Okay. And how does this work in a rural area where there aren't any really high hills or big buildings, and the commercial sites aren't interested in public service hosting of antennas on their towers? And there's no hybrid internet radio potential because there's no internet either.
How does it work now to get repeaters up in those same areas?
That I don't know, but I don't think they have a lot of them there.
Yeah, if you can't, I mean, if you had access to a site, even if it wasn't on a tower, and it was on the same property that allowed you to do that, you could probably put up a little, a small hut or something like that, attach a pole to it. These don't require a lot of weight handling unless it's in a snowbound area where you're going to get snow and ice loading.
Someone wants to know about using instead of doing a manual site selection process, using an RFU shed package like the Radio Mobile Online, and they provide a link in the chat if anyone is interested. That's Dan. Dan, maybe it's better you unmute and ask your questions directly.
Yeah, I don't quite follow that question.
WL7COO, you want to unmute and ask your question?
Yeah. Hi, Steve. This is Dan in Mariposa. As you well know, I respect ham WAN immensely. And as a cellular end node in an urban area, it does everything you say it does. But some of the alleged calculations for the number of radios you need for a mesh and the ease of maintenance once it's established, you might want to reconsider. So Radio Mobile Online does, it's like an online version of a professional RF viewshed that even includes some internationally accepted ground coverage mapping, so you know what you've got in the way. And with that, I mean, you still have to do the manual, you know, can we get a radio up on this repeater site or cell tower, just like the process you propose, but it'll show you the estimated throughput based on the known vegetation coverage between any 2 points you pick in the globe. So if you haven't tried that, you might find it.
Any better tool that you have is gravy. I was trying to show here the bare minimum and you know how you could start without a lot of tools. If you have the tools and that's available, go for it. The link counts that I had, I mean, if you have a link, you need a radio at each end. So
In a mesh, one radio can talk to an undefined number of other radios in that mesh.
well, okay, but you're talking about essentially comparing a vertical antenna to a beam. And these link antennas have like an 8-degree beam to them. So it doesn't have a lot of flexibility there. If you have a flat panel antenna, it doesn't go as far. And yes, it could pick up signals from several directions. So there's a number of variables there that I was trying to keep simple.
Okay, I didn't catch, I couldn't see the image long enough to tell what radios you're using, but I think most wireless internet service providers have either different radios or different antennas for their base radios that can be omnis or, you know, 3-degree or 5-degree high gain beams or sector antennas like cellular coverage.
Well, the sector antennas are 120 degrees. So there's 3 of them on a tower and that will take the client connections.
Except for those that are 180 degrees or 90 degrees. They're different sector coverage antennas. I don't want to argue because what you have is valid. It's very valid.
No. If you want to do 180 degrees, that's fine. You put 2 of them up. If you want to do 90 degrees, put 4 of them up. It doesn't matter to me how you design it, but the calculations I was doing was specifically for the links and the very directional antennas at the high level.
Right, but just so, and this I don't know about Hamwin. Do you have to create static routes for every link?
No, they have a DHCP pool that they put on the microtics that are at the highest level sites, and so I'm on a dynamic IP. I'm not on a static IP.
No, I'm talking about the routes. In other words, if you're going to go from someplace to someplace else, I guess in the Hamwin you're always going to the core or the center or the cellular.
Yeah, if you're a client, you're going to the sector antenna. If you're up on the core, they're running OSPF as a networking protocol. And yes, you have to figure all that out ahead of time. And those are, you know, you associated a cost with each of the routes, so you know where you're going to and so on and so forth. There's a lot of complexity there that I was trying to not put into this conversation.
OSP, open shortest path first, you don't figure
Correct.
out, the radio does.
Okay, can we move on here? Okay,
You want to handle Marty first?
Yes,
Next,
huh?
Dan?
We
yes,
should continue this offline, Steve, at your convenience.
yes.
Okay.
Marty, you want to go ahead?
Oh, thank you. Good evening. Steve, I'm wondering, as a practical matter, do you normally leave your network disconnected from the internet? Reason is, once it is connected to the internet, you now have to worry about all these users, many of which, or most of which may be non-hams at your client, sending traffic that is not allowable on the amateur frequencies under Part 97.
Well, most all the things I do are outbound, so I'm not terribly worried about people coming in. Although I have set up some rule sets in the MikroTik, I also have, which I hate to admit is not implemented yet, I have a firewall behind the MikroTik radio, and then it's off to a single computer. So this computer is not connected to anything else at my QTH at all.
I guess I'm talking about the network as a whole. I mean, you know, if you've set it up so that somebody in one part of the state can talk to somebody at an EOC in another part of the state, and they have connection to the internet, you have a huge number of potential clients who could accessing the internet for things that are business and not in compliance with 97.
It's an educational issue. It's just like any radio license. You have to know what you're doing. And essentially, I am the control operator for my node. So I need to, or my client, so I need to make sure I'm doing things right. And anyone down at some other served agency or something like that, you put one down at the Emergency Operations Center in your county, you hopefully will have just the hams down there operating it, because I really wouldn't want somebody else doing that and jeopardizing a license.
Thank you.
But it's an education issue.
All right, back to you,
Want me
buddy.
to do questions from chat?
Yes, back to you.
Okay, what kind of, Jay from North Carolina wants to know what kind of radios you typically use and on what frequency?
Well, I showed a picture of the integrated unit. Let me back up to that picture right there. And this, the very back end of this, so there is the microwave dish right here. That's the antenna. There's an integrated radio right there. So my connection coming off this wire, that's not an Ethernet cable. So the Ethernet cable comes into my computer, and the radio is actually at the back end of this antenna.
Okay.
And it's at 5.9 gigahertz.
Okay. Okay. Can you have multi-point microwave links?
You could on some of the flat dishes. On this one, there's probably nothing else to be pointing to, but yeah, you could probably have that.
Okay. Does HamWAN use Part 97 frequencies? Are you accessing commercial content, e.g. Google search or mail?
So they are in compliance, as far as I know, with Part 97. You can't go to a website that has HTTPS on it, because that is an encrypted mechanism. And if the mail goes over that, which everybody seems to be moving to, that can't be done. There are other programs that can be used, and I want to say Orv Beach down in Southern California, who's one of the Arden supporters, has a whole list of them. And he has tried them out. They are using a lot of them, and they are very careful and very selective about what they put on their network.
Okay. Can you recommend an email server for use on a network that's not connected to the internet?
Can I recommend a server?
Email server.
You mean email client or the email server?
He says server, but it could be a client.
I mean, I'm running an email server at home, and I'm running it on a Raspberry Pi. But I'm just using the standard protocols that come with that. And as far as I know, I could move that over to HamWAN because there's no encryption involved.
Okay. Brett from Salem has posted some links for the Oregon Arden radios that are supported on their Mac in the chat if anyone is interested. He suggests using an Ubiquiti EarMax Nano Station NSM5 as the first device for this. And Steve from Tennessee posted a whole bunch of WinLink interfaces for mesh in the chat. Okay. And Bill Curry says Radio Mobile is an excellent analysis tool. However, the learning curve is steep. Okay. And this is all under FCC Part 97, correct? Like you said. Okay, let's see. Okay. Tom from W3TDH says that he's installed communications shelters all over the hemisphere. One relatively cheap shelter is an outdoor walk-in refrigeration cooler. 2 people can carry it in any part quite a distance. The costs you would be quoted will include the refrigeration equipment that you will not be buying. Don't get scared off. There are some available in the used market. So that's an idea for a semi-transportable node. Okay.
That's
And let's
interesting.
see, the MidAtlantic Internet Protocol Network, or MAITN, uses non-ham frequencies. Okay, that's interesting. And is there a remote control capability for each radio? That's a good question.
I actually don't know. Sorry.
Okay. That's all the show. Dan has his hand up in the chat again, Dan. You
Sure
wanna-
does. Dan, go ahead, take it.
Steve, so are you using the manufacturer's operating system on this, or do you have a separate firmware flash?
Using the manufacturer's operating system.
Okay, so I'm just thinking that if you're not using, in that case, why are you using amateur radio freaks instead of the WISP? Well, you'd have to use ISM instead of WISP allocated freaks. But for the distances you're going, you might get away with that. And then,
Since
internally, as long as you don't go out on an amateur radio freak, you can do anything anybody else does via their internet infrastructure.
Well, that's been a point of discussion. And since the ISM frequencies are encroaching on the amateur radio space, you can move up or down a little bit into that spectrum. And you could, in fact, have a non-Part 97 network just operated by amateurs.
Okay. And are there a set of, well, I guess this is an emergency management focused system. So are there a set of EMA tools that you run on your HamWAN cellular cluster, whatever you want to call it?
Well, it isn't a emergency management system. It's just that emergency management folks tend to like this because they had it a FirstNet type of capability 5 to 7 years before FirstNet was actually able to deploy.
Okay. Last question is, do you know what your throughput is in megabits per second?
Well, my personal one is 14.4 up and 14.4 down.
That's usable.
And that's just fine for me. But the other faster speeds that we're showing were the ones between the link sites.
Thanks.
Okay, Tom, you want to take it?
Yes, thank you. The Mid-Atlantic Internet Protocol Network is run by hams, and they're using non-ham frequencies to meet the needs of served agencies for, some of the things that if it were ham radio, we'd have to exercise a lot of diligence to prevent them from using. So that thing goes from southern Pennsylvania all the way down to southwest Virginia. And it's just point to point, but they've got a few redundant pathways in it. And then they put in what they call off ramps. Now, I'm not a computer guy. I'm a site building guy. I was an electrician. And so I built a lot of sites from Tierra del Fuego up to Alaska. It is possible to put in these sites for not exorbitant money if you're willing to put in work instead. And I think that's worth saying. And they can be a tremendous asset to like emergency operations centers and hospitals. Because like here in the Mid-Atlantic, all it takes is a 1/4 inch of ice and all our lovely overhead wires turn into a plate of burned spaghetti laying in the street. And that, cuts everything down. So this sort of thing can be a good bridge past that sort of disaster. Back in that.
Okay, Steve.
I thought that was just a commentary. I didn't know there was a question in there.
Okay, that's fine. Do you see anything more there, Barry?
Just a couple of comments from Brent and Salem. He said amateur radio frequencies, at least in the microwaves, have a lower noise floor and have less QRM, so they get more range from using the amateur radio frequency. And throughput is based on a channel width and signal to noise ratio and range. Under Arden, 10 megahertz width practically supports up to 70 megabits per second at short range. I guess that's just a commentary.
I guess the definition of short range should be brought up here too, because you know, some of those links, the first hop off the node that I connect to is 69 miles, something like that. And so they're getting 86 megabits per second on that link.
In Florida, we have a system called Florida Sarnath, which is all amateur radio frequencies on the 70 centimeters. They're different actual repeaters, but they're not linked with the internet. They're all linked via the Department of Transportation microwave network. And so we don't have to depend on the internet going down. As long as you aim the microwave dishes properly, and during a hurricane, you check to be sure that they're all bolted down, because during one of our hurricanes, the entire network was knocked offline because the microwave dishes were blown aside a little bit off of their aiming points by the wind. So that's something you got to take into account when you're setting up a network like this.
Yeah, you have to worry about yours being blown off alignment. We have to worry about ours on this coast being shaken off alignment.
Right. But they work wonderful when they work.
And the question about the WinLink peer-to-peer, I don't know. I haven't tried it yet. I'm anxious to try it.
Okay.
Okay.
Looks like we're done with the questions in the chat.
Yeah, I was going to say, anybody else got anything?
Yeah, when you're putting those dishes in, since I did a lot of site work, if you put your rack across the side of the tower instead of trying to stick the dish on a corner, which is more work and takes more materials, then when you anchor the dish down, it's much more resistant to twisting and so forth. If you rack it across the side of the tower rather than on a corner of the tower, for what that's worth.
Well, thank you, Tom. Anybody else got anything out there? Bunch of hands sure being quiet. Well, Steve, that was a good presentation. I thank you very much.
Well, I hope people are enthusiastic about doing it themselves. That's what I'm looking for, is getting more people onto this type of networking. So that's my thrust.
Okay. Yeah,
The
be
younger
nice.
hams really get into this kind of stuff. If you want to turn them on to ham radio, show them what you can do with microwave networks and on the gigahertz band networks. They will really get their eyes lit up and get motivated to get involved. Some of the older people, not so much.
Speak for yourself there, Barry.
Yep.
Okay. Are there any other questions or comments?
I'm getting very interested in 60 gigahertz, excuse me, because that's sort of right in the middle of where Starlink is using its phased array antennas.
Okay.
Microtech has a couple nice 60 gigahertz units out, and you get, I think, a mile and a quarter on them. So for linking, if you have going from one building to the other, or going from your the building you've got your equipment in up to your ham WAN unit up on the tower, you could just do it via microwave up on 60 gigahertz. You're on the ISM band.
Well, there's uses, and I for densely populated urban areas, what you're doing might make more sense. You just got to figure out how to integrate it into, an amateur environment and culture where you have some control over people not using it the way they shouldn't be. And in your case, if you're just using ISM freaks, there's really no problem. And Arden has been very responsible about dealing with that. So I think there's a marriage to be made here.
And the
Well-
links for this will all go out tomorrow. Dan will send them out
Yes,
tomorrow
sir.
along with PDF and the slide deck.
Yes, I always send out all that. Tom, you got your hand up?
Yes, sir. I've got a use example people may like. We had a apartment house blow up and all the people were sheltered in a recreation center, but it was in a stream valley where the county happened to have room. So none of their phones and all of that stuff would work. And a couple of members of the club, not pre-organized, set up one of these links that he's talking about between the top of the hill on a tall building and down in that recreation center. And all these people who'd had their lives turned apart had this spontaneous link back to the world where they could send email and tell their loved ones they were okay. And it was just, you know, a couple of guys hustled it. So there is a lot of value here.
One of the things, I had one more piece of value here that the city of Portland is going to be implementing in the next few months. They have a ArcGIS server that does mapping very, very well. And they're going to use an app, a phone app, to allow these CERT people to answer little surveys when they're out and about assessing damage and things like that. What we're thinking about doing in our county is essentially the same thing, although have a HamWAN capability so that the CERT people could drive or get close to a HamWAN link and folks would share out their Wi-Fi units, the Wi-Fi connections that are connected to the HamWAN, and that would actually go back down to the Emergency Operations Center. And as the surveys come in, they would populate almost in